Good day everyone, welcome to all. My name is Sachin Ahankari, working as Assistant Professor in NRCM Engineering College, EC Department. So today in this session, we will see about the basic information of op-amp. Some basic information, and we will also see some of the ideal and practical op-amp characteristics. So these are the basic information about the op-amp. We have already learned a few things. Again, I am going to uh, revise the things in brief. That is, op-amp is a very high gain amplifier fabricated on integrated chip. It is a combination of many transistors, FETs, resistors in a pin, and it finds the application in the audio amplifier, signal generator, signal filters, and biomedical instrumentation, and various other applications also. So what are the advantages of op-amp over the transistor amplifier? So few points we are going to cover, that is advantages of op-amp over the transistor amplifier is less power consumption, since IC is going to occupy very less area than the transistor amplifier uh, in practical. So less power consumption uh, due to less area and less power supply. So less power consumption it is going to give to you. The cost is less as the ICs are manufactured or fabricated in large scale, then the cost of IC is going to reduce. Therefore, the cost is also less. It is more compact than that is more compact means in less area it is going to occupy than the transistor amplifier. More reliable and high gain is obtained since op-amp is having the various differential amplifiers stages, so they are going to provide you the higher gain, and it is easy to design. So these are the few of the advantages of op-amp over the transistor amplifier. So we will see again few of the basics of op-amp here. So selection of IC package. So there are op-amp is available in three type of packages: metal can package, dual inline package, that is DIP, and flat pack. So metal can package heat dissipation is important, and for higher power applications like power amplifiers and voltage regulators, the metal can packages are used for higher power applications. Dual inline package for experimental or breadboard purposes, as it is easy to mount on the breadboard. Uh, so we are using the dual inline package in the practical or experimental purposes. If the bending also or soldering of the lead is not required, suitable printed circuit boards as lead spacing is more. So these are the criteria for selection of DIP, that is dual inline package. It is suitable for printed circuit boards as the lead spacing is more. Therefore, dual inline package is used, and the flat package is used where you require more reliability, and it is light in weight. Also, it is suitable for the airborne applications. So if I go for the few of the pictures of the packages, so these are the pictures of the packages, that is metal can or TO package. The second one, that is practical purposes, we are using dual inline package, and the third one is flat pack package. So these are the two packages in which the op-amp IC is available. The equivalent circuit of op-amp, it is as shown in figure. You are having the input resistance in between between the inverting and non-inverting input terminal of op-amp there is an input resistance, and ideally the input resistance is infinite, means it is open. Ideally it is open, but practically you are having some resistance over there. It is indicated by here Rin, and AOL into VD, it is acting as a voltage source here at the output, and AOL is the open loop voltage gain, and VD is a difference voltage between uh, non-inverting input terminal and inverting input terminal. So AOL open loop voltage gain is multiplied with difference voltage, and this is acting as a voltage source, and R0 is the output resistance. Ideally the output resistance is 0, and practically the output resistance is uh, 75 ohm. So you are attaching the power supply VCC and minus VEE. The supply voltage range for VCC and VEE is 15 volt and minus 15 volt. So this is the equivalent circuit of op amp, and if you go for the factors affecting the selection of IC package. So these are the few factors which are affecting the selection of IC package: relative cost, reliability, weight of the package, ease of fabrication, power to be dissipated, and need of external heat sink. So these are the factors which are affected for the selection of IC package. And if you go for the temperature ranges, we are aware of the temperature ranges. The military temperature range is from minus 55 degree centigrade to 125 degree centigrade, and industrial temperature range is 20 degree centigrade to 85 degree centigrade, and commercial temperature range is 0 degree centigrade to 70 degree centigrade. So these are the temperature ranges for the commercial IC purposes, industrial ICs, and for military temperature ranges. So these are the few of the basics of your op amp. Now we will see the ideal and practical values of op amp, or some of the characteristics for ideal versus practical op amp. So open loop voltage gain is infinite, that is whenever the op amp is not connected in feedback loop, like when you are not applying any feedback, then at that time the open loop voltage gain is infinite for ideally, and practically it is having the value from 10 to the power 5 to 10 to the power 7. Open loop bandwidth is also infinite. If the bandwidth is infinite, it can amplify uh, the signals from zero frequency to infinite frequency. So that's why the bandwidth must be infinite. Uh, CMRR, actually it is infinite, and practically it is 4 megahertz, or various ICs are also providing more than 4 megahertz. So 1 megahertz to 4 megahertz, it is a practical bandwidth of the op amp. Ideally it should be infinite. The CMRR value is infinite, and the practical value is 90 dB approx for 741 IC. Input resistance is also infinite for the ideal op amp, and the value of input resistance is approximately 1 to 2 mega ohm practically. In similar fashion, output resistance is 0, and practically the output resistance of 741 IC is 75 ohm. The input bias current is 0, and input bias current is less than 50 nanoampere. The offset voltages are 0, and they are less than 10 millivolt practically. Similarly, the offset currents is 0, and the practical value is less than 50 nanoampere. The slew rate is infinite, and it is having a few volt per microsecond practically. The drift is 0 ideally, and the drift is low practically here. In similar fashion here, the CMRR is covered. So output voltage, it depends on VD ideally, and here practically it depends on the not only on difference voltage but also on the common mode voltage for the output voltage. So these are the few uh, characteristics, ideal and practical op amp. We are going to compare ideal and practical op amp. So these are the values. So we will cover in the next session all these terminologies, how they are defined, that is all the characteristics of op amp, and after that we will cover AC and DC characteristics of op amp. So I am going to stop here.